All right, so this is week 2, the importance of data science in the world of technology. And we will discuss all things that are related to data analysis. And we will also review the topic from last week because that proved to be very complicated. Yeah, so we're just going to wait before we get started. We're just going to wait for more people to join us, a couple of minutes, and then we will dive right in and begin by reviewing binaries, which is what we ended last class on and was very complicated. So I'm going to ask a couple questions just to understand that we kind of have a holistic understanding of the topic. Hello, everybody. Welcome. We will begin shortly. People are still joining. So as soon as in a couple of minutes, we will begin. Welcome, everybody. If I may ask that you please mute yourself for the beginning, and if you have any questions, feel free to unmute or raise your hand or ask in the chat, whatever works. Okay. Then we will begin now. If anybody has questions, I think it's easier just ask in the chat. Anybody would like me to slow down or repeat something, feel free to ask in the chat, raise your hand, or just unmute. We will now begin the first lesson, or the second lesson. This is week 2, where we discuss data and data analysis. I'm going to ask to mute. Okay, so today to begin, we're going to do something a little differently. And that is, we are going to do an icebreaker. So I would like everybody or whoever is comfortable to either in the chat or unmute and go around and say your name and one piece of technology that if you had the opportunity to, you would put in a time capsule. I want you to think about how this piece of technology affects your life. It can be anything. It doesn't need to be the device that you're currently on the call with. Technology is so much. And how not having it would change your life. I also want you to think about bigger picture. What would the whole world, sorry, let's just say world, what would your whole, not just your life, but how would the whole world look without this technology and why it's so important? So take a couple of minutes to think about this while more people join us. And then you may share out in the chat or unmute or raise your hand. And I would like some people to share out and discuss this. If anybody's ready, they may go ahead and share.
Ashwag.
Can I go first?
Yes, go ahead.
For me, it would be Google Maps, because without that technology, I would get lost all the time, including in my own city.
Yeah.
So I can't even imagine not having a map. And I know that when I was younger, there wasn't such a thing, and I did get lost all the time. So it took me a lot longer to get places.
Yeah, that's a very good one. Yeah, so Google Maps is something that is a kind of technology that has been updated and updated to become more and more efficient. So obviously it started with paper maps, and now it's in this idea where it's something that is kind of been digitalized, and a technology that, even though we'll keep updating and updating, will kind of have the same use. Does anybody else have any other ideas or any other things? Repeat the question. Yeah, so some people are new, just joining us. We are beginning our meeting with an icebreaker, and the question is, if you could have one piece of technology that you would want in a time capsule, you would want to put to, preserve, what would that piece of technology be? And I want you to think about why. When I say why, I mean, how would your life look? How does it affect your life? And how would it look without it? And what would a world without this piece of technology look like? I'm seeing some people in the chat, so I'm just going to read the chat. But if people would like to unmute, feel welcome to. Someone is saying, for me, it's Google. I get answers to questions in seconds. Yes, that is a very good one. Google is a great software, as we discussed last year. It's the difference between software and hardware. So you use a hardware, a piece of device, to obviously search on Google. But yes, Google is a great piece of technology to kind of answer all the questions on.
Hi, Julian. Can I go?
Yes, go ahead.
Okay, for me is the AI, the artificial intelligence. It has helped me a great lot. Some questions that I can't actually find solutions to. Whenever I go to the AI tool, it gives me a headway on how to solve that particular problem or question. Thank you.
Dorothy, what do you typically use it for? And which one are you using?
Okay, actually the particular one I'm using right now is ChatGPT. You get it to write some essays, and she gave you step by step on how to go about little things that ordinarily you are taught and you're not cleared on. But when you optimize, when you ask the question in a nice way to the ChatGPT, it has a way of breaking it down in a simple term for you.
Yes, that is also a very good one. Obviously, AI is something that has been around for a while, but it is this idea of ChatGPT where it can answer your questions is something a little newer. So that is a new, very good piece of technology.
Can I say something?
Yes, go ahead.
Yeah, I will talk about Google Sheet. Since I got to learn about Google Sheet, I use it to plan my day-to-day activities. And when I share it with my partner, when I give him the right to be a commenter or an editor of my sheet, he can also add whatever he remembers on how to run the home. Probably things we want to do. Maybe we want to arrange a room, we want to do some things. It's like a reminder. We just store things there. Unlike if we are the ordinary episode, I couldn't have shared my sheet. So Google Sheet helps me to plan my day-to-day activities and do every other thing.
If I could ask that you please mute yourself if you are not talking. Thank you. That is also a very good one. Like spreadsheets.
Chris.
And the ability. I'm sorry if you could.
It's okay, Julian.
Yes, the ability to share documents and have many people collaborate in one plane is a very great feature. I'm seeing a lot of people in the chat saying Google, where they can search questions. Definitely. Would anybody else like to share, or if not, we will move on.
I was going to say, hello, good evening, everyone. For me, it will be the Microsoft Office suite, so you know your Word, your Excel, your PowerPoint. And then as a BA, for me, it will also be things like Visio, which helps me to like prepare process maps and do a lot of customer journey mapping kind of thing. There's so many others that I could, literally talk about as well. Microsoft projects as well.
Yeah.
Your VI, that helps with visualization of data, and then you can literally get insights from data that you've put together and cleaned and tracked.
That's actually a great segue, because today what we will discuss is data and the ability to analyze it and the ability to change it and read it. And yes, Microsoft Office and all the tools that it offers is a great way to do so. So if there are not any other technology that is very important to you, if anything else comes up, feel free to say it in the chat and we can talk about it. And if there's any questions, you may also ask in the chat or unmute. I just had someone in the chat say Google or AI, so to answer questions. Google, yes, Google does the job, and it has for many, many years. Any question you have, you search it, and within seconds, you get all the results you can ever have. So yes, that is a very handy piece of technology. We will now move on. For those of you who are just joining us, we're just beginning the icebreaker, and now we will move on, and we are going to discuss a little bit about what we went over last week, because it was a very complicated idea. So I have typed up some notes for the last lesson, and if I will, at the end of class, I can send them out, or if you would like to email me, I can send them to you, but feel free to ask me, because I know it was very complicated. So we're going to begin with a little review about binaries, because when analyzing data, binaries become very important, because the whole point of this is to create a system where you can efficiently process data with the computer. So the reason binaries are so efficient, the reason they're so small, the reason that you can only have a 0 and a 1 is because even if you do have thousands of these, which you might have, which might only become a gigabyte or a megabyte, and which is still a very small amount of storage, you can say so much. So if the moment you include the ability to say a 2 or a 3, you already become so many more options. It already becomes so many more options that you need to think about when you have to multiply these, because you're not only using one of them, you're using thousands and thousands, right? So everything can be represented with one byte. And I'm going to revisit this idea of a byte versus a bit, because I understand they're similar, and therefore it became very complicated. So 1 byte is made out of 8 bits, and every character, when I say character, I mean a number, an uppercase letter, a lowercase letter, a symbol, a parenthesis. Think about any symbol, a stir, anything can be represented with 1 byte, which means 8 options between 0 and 1. So a bit is either a 0 or a 1, and with 8 of these options between these two, you can say anything, any character, any symbol, anything. So now I will ask a couple questions just to ensure that our understanding is kind of more holistic about this. So I would like to begin with giving you guys a couple minutes to convert the binary number 010111010. So notice how I read it from left to right, because it gets from smaller to bigger, to its number equivalent. So take a couple minutes, share in the chat. If you finish early, you can do a private chat to me. My name in the Zoom is Tech Dreamers, and then we'll all share out and figure out how to do this together. For those of you who are just joining us, you haven't missed much yet. This week we are discussing data analysis, which was requested by some of you. And we are doing a quick review on binary. So I've just asked this question. So if you could take a few minutes to answer this, that would be great. People are saying they can't hear. Are people having problems hearing me or? Okay. Please let me know if you're having trouble hearing me. But if there's a way to turn up your volume. Okay, we'll take a couple more minutes. Okay, so now I'm going to review how I did this. So yeah, I'm getting lots of people in the chat saying, okay, people can hear me. So yes, I'm getting lots of people in the chat saying that's 90. And I'm glad that people are kind of getting an understanding of this. And I hope that everybody kind of will understand it by the end of this. Yeah, we're having more and more people joining us. For those that are just joining us now, we are going over binaries, and I just asked this question. So we will now see how I did this. So for those of you that kind of had trouble, feel free to ask any questions in the chat or unmute. But I will now explain how I did this. But I'm seeing lots of people are getting 90. So the lights that are turned on. So each binary has a value. Let's start with that. The first one, a 1, and then every time it doubles from there. And you add together only the binaries that are on, in our case, like the light bulbs from last week that are on. When I say this, I mean the ones that are turned to 1 are on, and the ones that are turned to 0 are off. So for us, the ones that are turned to on are 64, 16, 8, and 2. Now, when we add those all together, we get 90. And that is how this binary, so see how something so simple, just a couple of 0 and 1s, can represent such a large number. And that is why they are so helpful. Now we will move on to the next question, which is a little more complicated. I want you to convert the letter L, uppercase, be careful of to be case sensitive, into binary form. Okay, I'm seeing someone has gotten an answer. In the chat, some people, yes, very good. People are answering. I'm going to give a couple more minutes, or 1 or 2 more minutes, and then I will go over it. Okay. People are answering. Okay, I see lots of people are answering, and I'm glad that so many people kind of have an understanding of this because I think last week we kind of ended and it was a bit complicated. So I will quickly go over for those of you who are having some trouble with it. And yeah, if you have any questions, let me know. So a capital L translates based on this chart to a 76. And then what we already know how to do is go from 76 to binary. So how we will do that is we will turn on the light bulbs, we will turn on the binaries or set them to 1 that we want to add the values together. So 64 plus 8 is 72. And then plus 4 is 76. So we have turned on 64, 8, and 4. And 64 plus 8 plus 4 is 76. Does that make sense to everybody? Or are there any questions before we move on to discussing data? Okay, so now we will begin by discussing data science. For those of you, some people are still joining us, and for those of you who are still joining us, we have just finished reviewing binaries and are now moving into data science. Now, the way these two topics play into each other so importantly and so greatly is because it is binaries that allows data analysis to take place at the speed that it does. It is because such a simple form exists to represent data that data can be processed at such speeds. Someone's saying that they didn't get that. Is it this slide or the last slide? Would you like to unmute and you have a question or about which slide? Is it this slide? Okay, I'll explain this slide again. So data science is very important because it is the act of using statistical methods, algorithms, and different kinds of technology to analyze and interpret complex data. So its goal is to kind of find patterns and extract insights and knowledge from both structured and unstructured data. Which allows for many things. So here are 3 examples of what data science or data analysis allows for. Firstly is like online shopping recommendations. So let's say you're online searching for anything. It can be clothing, it can be food, it can be like battery or any parts for anything that you need. Data science takes all the data of your searches and helps use it to find patterns and better understand what it is that you're looking for. So the slide before, okay, yes, I will repeat the slide before. I'm just going to finish discussing this slide first. Another thing is health alerts. So hospitals use data science to predict diseases. If they can find all the symptoms of many, many patients, and they can find patterns, they can say all these patients from this set of data have the same symptoms and therefore the same disease. And then similarly, the same thing can be done with theft, more specifically credit card theft. So banks use the data of where charges have been made and they use patterns. So if every day you spend money and you buy a coffee, and then every day you spend money and you buy a book for your school, but then suddenly you spent $500 on a new bicycle, let's say, or anything. This pattern is abnormal because every day you have this routine of spending these 2 pieces of money in this set of day. So it will look through this data and say, we've never seen this before, and therefore can't detect theft. So analyzing data helps all these applications, but many more, by uncovering patterns and predicting outcomes, and with that making informed decisions to kind of help many experiences, services, etc. So now before I move on, I'm actually going to review the last slide one more time. Okay, so if anybody has any questions, feel free to stop me. But Okay, so, so we are trying to represent a capital L with, binaries. Now, based on the chart that we were given in the last slide. Based on the chart that we were given in the last slide, we know that L is 76. Correct? So now we know that we must represent 76 using binaries, which is what I've shown at the top here. So to represent 76, we have to turn on, or we have to set the binaries to 1 of the numbers that we want to add together. So I know it's complicated, but from binaries, the first important thing is to know that you go from left to right. So we're going to begin here. Now, the first binary will always have a value of 1. And then from there, it will always double. So from 1 to 2, it doubles. From 2 to 4, it doubles. And so on, until 128. Now, in order to get any number, what we need to do is add together in the most efficient way the numbers that will get us to 76. So to begin to do that, we will take 64 because that's the closest we can get to 76 without going over. So it is smaller than 76, but it is very close. So we will first take 64, which is why the binary is turned on. Okay, since 128 is too big and will bring us over, the binary will be turned off. Then 64 plus 32 will bring us over 72, so we can't use that. So that binary also needs to be off. Same thing with 64 plus 16. 16 plus 64 will take us over 76, so therefore it is also set to off. Now, 64 plus 8, however, brings us to 72, which is not over, but not perfect.
Are you watching you?
Sorry? Someone say something? Yeah, so which is not perfect, but it doesn't go over, so we can use it. So therefore, we will set this binary to 1, and we will add 8 to 64. So when we do 64 plus 8, we only get 72. So we need another 4 to really get to 76. So then we're going to turn on the binary for 1, or we're going to set it to 1, and add the 4. And now we are at 76, so we don't need the 2 or the 1, so those can both be set to 0 or be off. So the only ones we need are the 8, the 64, and the 4. And those are also the only ones which are set to 1. Does that make more sense? Does that make sense to everybody? If you have any questions, feel free to speak in the chat. Yes, okay, it's clear. Thank you. I'm glad it makes more sense. I'm sorry that I kind of sped over. Now let's move on to discussing data science. If you could please mute. Okay. So yes, data science. Okay, so data science has many different practices in the real world. One moment, please. So in the real world, data science or data analysis is simply the process of analyzing and sorting data. And it is very important for many reasons. And when we think about data science, I want you to think about it like it can be compared to humans. So just like if you were reading a book, you could read less pages faster, a computer can go through less data faster. So the art of data analysis is to take a set of data or take an amount of data, a set amount, and kind of make it as little as possible before you're actually ready to process it. And there are many steps that can be taken to do so. Yes, so the first thing that's very important for data analysis is actually having a set of data. So data is the key component in data science because not only is, or a data set, because not only is it just a whole amount or a whole bunch of data just randomly there, but a data set means it's organized, it's labeled, and it's in the order of what you want it to be. Data sets are only as large as they need to be, because if it's larger, it simply takes more time to process, to do anything with. So a data set will only have the information it needs. So an example is, so a data set also depends on space. So if less space is available, a data set will be smaller. So this is actually an issue in a lot of places, because if your computer or your device doesn't have enough storage, but you need to store a lot of data on it, it can't do certain actions because it needs this much data, but your computer only has space for this much. I will go to an example. Are there any questions about this? Sorry. Okay. So let's think about an example. So imagine you've been keeping a journal, tracking your daily activities, your sleep, your mood, what you eat, everything, your personal health. You've been keeping a journal. And
Please, can you please can you get back to data set again?
sorry, sir, you have a question?
You want to get back to the data set slide again.
Oh, okay.
Please, can you get back to that
Yes, I'm back here, and I'll explain it once.
data set?
So yeah, this is the slide. So data sets is where it's the process of compiling all your data, but not only compiling it randomly, where it's in the right order and it's made as easy as possible for a computer to process. So imagine you had to read a book in the wrong order, where the pages were all scrambled. Would that be easy to read? Could you understand what the book was saying? No, probably not very easily. You could get like a rough idea of the characters because you see a name, but if all the pages were in different orders, it'd be very hard to understand what's happening in the book. It's the same thing with the data set. Before a computer wants to read and analyze data, it needs to put it in the right order.
Celebration, Balotelli, the Hakem Nonga Yibo to celebration, the Silver Light, Edgy
You have a,
celebration, the Travology, then La Lova Fancy, Phone from a fancy on Hebo.
okay. So yeah, so just like reading a book, if it's in the wrong order, it would be very difficult. Computers, before processing data, it needs to be the right data, which means only of what wants to be processed and in the right order. So to go back to the book analogy, imagine the pages of two books were mixed into one. It would also be very hard to read. So you need all the same data that represents the same stuff and in the right order. And those two things are very important. Okay, so for example, imagine that you had a journal where you kept track of your health. And for the last month, you want to take the data from the last month and see what activities led to a better mood. So you wrote down what activities you did and how much energy you had and what you ate. This is an example of a data set. If you wanted to do that, you would only take the data from the last year and you would put it in order, and you would take it for what you ate and what your mood was. And that exactly is a data set. In your mind, you only need to think about the last month. So you can first cut it off there, and you only need to think about food and mood. So you have those two data sets, which makes you don't have to think about anything else, even if you wrote all these other things down. And that is very common in computing, where a computer can record a lot. But it only needs certain things. So it will create a data set and take certain things out of its recorded data to then analyze and use for any like daily use that it needs it for. We'll go over an example later, a full example. Let's move on to data wrangling. So data wrangling is the process of converting data from its raw form to a tidy form ready for analysis. So this includes cleaning it, finding missing data, putting in the dates and times, and it's an important step because the more tidy data is, the better and more efficiently it can be processed. So once again, the goal for data analysis or data science as a whole is to do steps that will allow computers, which are what we've gone over before, this device or this hardware or not just hardware, but this holistic device that can process data. And at the end of the day, that's really what a computer can do. But there are all these steps in data science that will make this process more and more efficient, including making it tidy and kind of wrangling the data. Let's find an example. Let's look at an example here. So let's say real world example is city planning. So let's say that you were there was a camera. There was a camera here. And there are 2 lanes with 2 stoplights. And in this camera, you only want to see who runs this red light. With data wrangling, you can cut out all the data where people ran red lights here because you only care about this lane. So again, you can think about this analogy for you. Imagine you had to watch videos of people running red lights in both lanes, and you were told to find how many people ran red lights in that one lane. Would it be easier to watch both lanes videos, or would it be easier to just watch the video of the one lane? It would be easier to watch just the one lane, which is the lane in question. So just like this, a computer is to create a smaller data set and because the smaller it is, the faster it can be processed. So the goal is to kind of take out all the unimportant data, which in this case is the traffic, this lane. So if we can remove all this and only have this, then the data can be processed much better. Is there a question? Let's see. Yes, there's a question. Yes, one lane, exactly. So it would be easier to do it with one lane, correct? Does everybody understand that? Yes. Or not? Okay, so someone, Fortune is saying, meaning it gives record of everything according to the command and specifics the method. So yeah, so in the same example of this camera, it records everything on the street, but you only need to know what happens in one lane, even though it records both. So the process of data wrangling is to kind of cut out all that data where red lights are run in the other lane, because you don't care. You only care about this one lane because that's just what the city plan wants. So instead of watching all these videos like you personally would have to, or the computer has to go through, you cut out. If it's in the left lane, you don't need it. If it's in the right lane, you need it. So then now you're only watching videos of this one lane. Oh. Okay, good. Yes. Now we will discuss another step of data analysis, which is data visualization. So data visualization is one of the most important branches of data science. And it's—
Can I ask a question?
Yes.
So data wrangling, is that useful, for example, also in astronomy, where maybe the entire sky or the entire area is being collected, and then you only want to focus on a certain type of event?
Yes, precisely. So let me just show it here to make it easier to show. But let's say there's a telescope looking at the sky like this, right? And you have many stars. Or you're looking at the orbit of a planet. But in this image, you see so much. But in your data, you only want to focus on one single event of one star or planet or etc. So then the movement, or when the telescope records anything else, it can cut that data because you don't care, you're not analyzing that, but that happens to be in your frame. So everywhere where I'm putting an X is unimportant, which means in the end, your data will only show the movement of the subject in question.
Okay, got it. Thank you.
Yes. Are there any other questions, or we'll move on to data visualization? So this is kind of a more final or a step towards the end, where once all your data has been cut out, you've found you've cut out all your unimportant data, and you've sorted it in the right order, and it's all clean and it's all the right data. You want to show it somehow. So most usually it's shown by graphs, and it's seen as more of an art than a science. So here we see this graph where temperatures are recorded, and so when you're recording on this data, you have a bunch of data about temperatures, but somehow you need to show that the average temperatures of the city are changing and are increasing and are decreasing, and you need to represent it all visually. So to do that, a graph is used. And here with this graph, we can see a lot about the data more than you can see by just looking at the data. So the first thing we can see, for example, is an increase in temperature. So rather than just a scrambled bunch of numbers where you have to see there was an increase, we can right away see an increase until July. And then we can see from July till December, it decreases again. And that is right away with data visualization. You can just look at something and say, hey, in January, it's pretty cold. And then until June, the average gets, obviously the fine data is it's not every day getting warmer and warmer, but on average, until June, it's getting warmer and warmer because it's summer. And then from June all the way to December, when you go back to summer, back from summer back to winter, it gets colder and colder again. So just so quickly, you can take a bunch of data, you can have your data sets, you can sort it, you can take out the useless data, and quickly have data visualize it on a graph like this. Does that make sense to everybody? Now,
Yes, it does.
this piece of data, for example, over here, or if let's say in July it got very cold and there was a dot here, right? That would pull your data down and break your average. So to avoid this, there is a step called finding outliers, which we'll discuss later. First, we will look at an example of data visualization, a more specific one. So, let's say you are recording steps. If you want to compare from 2016 to 17, how many steps you took, what's the best way to do that? A graph. And that is all that visualization is. Some computers do it more complicatedly and some do it simpler, but it's however you want it. But in a way, the simpler it's visualized, the easier it is to see. So here we right away look at this graph, and what do we see about how can we compare the steps of September to the steps of April? We can say, hey, look, in April, it might be a little warmer, so I spend more time outside and have therefore walked more. So from September to April, there's been an increase. But then in November, it was pretty cold, so maybe I took less steps. Does that make sense? And in May, where it got even warmer, I took almost 9,000 steps on average. You understand? So the idea, the essence of data visualization is that it puts together all these ideas that we did, all this work where we crunched our data, we wrangled it, we took out all the useless data, we put them all in order, and then finally you need to show it, you need to present it somehow. And this is that step where you present it. Are there any questions about this? Okay, great. So now we're going to discuss outliers. Let's see. An outlier is a data point that is very different from the rest of the data set. So outliers are often seen as bad data, or they're just, so when you take a measurement, there's obviously not everything's going to be the same. So, but identifying an outlier is very important, because an error or a malfunction sensor or a broken measuring device can completely throw off data. So if you have a data set and you see one set of data that's kind of off, so okay, let me use this example of data visualization, which I will show an example, but let me also show now. So if you have a graph and like this, and your points are kind of, they're like here, right? And then suddenly you have a point here, and then here. When you go to make your graph, you're going to have a huge arch, even though this outlier, which shouldn't be there, is being, so the outlier which should be there is being shown, which means it will cause your graph to become an arch. While if it wasn't there, it would be a straight line and kind of show a good best fit. The idea I'm trying to show here is that there will always be error. There will always be things that are different. There will always be that one person who runs a marathon every day and will have many steps. And when you're trying to average it, let's say you're trying to average the steps of many people in a community, that will pull the averages up. So you always have this set of data, as we discussed, that will be very similar. And then there might be data that's very different, either high or low. And outliers are important to be cut out. So this kind of goes under this idea of data wrangling, but it's a little more specific. It's not this whole group of data, which is wrong, this whole lane of footage, which needs to be cut out. It's more, he was a guy who was didn't know how to drive properly, so he ran the red light. And that's the essence of outliers. Here is a better example than my drawing of what an outlier looks like. So as we can see, as we can see here, here's a graph, and it represents the height of people. And most people are between 165 centimeters to 185 centimeters. So they kind of fit through that, they fit in that where all those dots are in kind of this range. Correct? So these are the average people. But then suddenly there's an outlier of one person who is 250 centimeters and brings the graph all the way here. So an outlier can significantly skew the average, the average height, and throw off any measurement. So there's always going to be something that's very different. But if we have an average here and we know everybody but one person is in this range, it's safe to it's fair and safe to assume for a set of data that is being processed that most of the data will be here, and therefore all of it that isn't can simply be cut out. Because here in this case, it's only one measurement. If there were dots all over here, that'd be a different story. But only one person is 250 centimeters, which means that one person is throwing off the average and represents a very small part of the average, and therefore can simply be cut out. Obviously, in real world examples, this works a little differently because it's the outliers that are important. But outliers always have a reason, and this reason will always be something that can be, in the end, detected as error in some way, which I will go through another example later. Yes, so an outlier identifies an exception. So more than as an exception, it would be kind of, yes, an exception, but something that you would cut off because it's seen as an error, or there's always going to be one difference. So it would be seen as something that you would remove because it is so vastly different and therefore will destroy the average. And also think about it like this. Let's say you had to read and everything was in order, and then suddenly there was one page from a whole different book. That would be very complicated. So instead, you remove that outlier, you remove that page from a different book, and then you can still easily read that book. And just like a computer can still easily identify and process the data of that range, rather than suddenly have to think about the range or the number that's all the way up high. So Fortune is asking, can you use a real life scenario as an example to explain more? Yes, of course. Yeah, so you're right, Angela. If it's an exception, then it needs to be studied. But in this case, outliers are mostly seen as error. So let's say you the day you measure wrong, or some sensor is broken or out of batteries and something is wrong. So outliers are more seen as if something was very wrong, then, or if something is very different, then most likely it is incorrect. So who knows, maybe there isn't actually someone who's 250 centimeters, because that is very tall to be. So if there's all these people in this one area in the same community, and all these people are this one height, and then suddenly someone's very tall, it's most likely an error, right? So yes, someone is asking for another real life example. So let's say you're measuring let's say a teacher is measuring when their student did their homework, okay? And let me just show you. And he put it on a graph, and it looks like this. So this is a graph, and this means no, he didn't do his homework, and this means yes, he did it. So on Monday, he did his homework, on Tuesday, he did his homework, and etc. Correct? But let's say suddenly on Friday, or let's say on Thursday, the student gets sick. And suddenly he didn't do his homework because he was out sick, right? But every other day when he was feeling fine, he did his homework. So it's that yes. Now, the graph will look like this, and the average is pulled down to Thursday, on Thursday when he didn't do his homework because of the day he was sick. But since it's such an outlier, it can be cut out because it's error. He was sick. How can he do his homework if he was sick? So what a computer would do is say, hey, this is super different. Why process this data if it's so different? It's a mistake. So let's erase, 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 and just say, you know what? He was sick, so we're not going to count that. And the student did his homework every day. And the average graph is a straight line representing, yes, he did his homework. Does that make more sense? I'm seeing some questions. Yes, it makes sense. Champion Lion is saying, can you explain the differences between an outlier and the cutout data during data wrangling? That is a very good question. So data wrangling is more this idea of a lot of data that is just not relevant. So if you're looking at 2 lanes of camera footage, but you only, or if you have 2 lanes of camera footage, but you only need 1, you don't need to, you can cut all of that out. And that's kind of the idea of data wrangling, that you're taking a huge chunk of data that you have a lot of, but you only need some of it, and you're cutting it to just be some of that. An outlier is more like a single exception, as some have called, more of a single thing, where there's a driver who was in the lane you were studying, but he didn't have his driver's license, so he didn't know that he wasn't allowed to go on red. That is an outlier, because your number of red lights run gets higher, but there is an error that he didn't know how to drive. So instead of people purposely, if you're studying people purposely running red lights, this guy didn't purposely do it, for example. So outliers are more the individual, like specific detail exceptions, and data wrangling represents more a holistic crunching of data to make something that's very big into something very small, instead of something that's small and has already been wrangled, and make it a tiny bit smaller by taking out those 1 or those 2 or those very small amounts of extra data that doesn't need to be there because it is an error, because it is an outlier. Does that make more sense? Let's check the chat. Yes. Or a driver that was neither on the right lane. Exactly. Correct. A driver that was on neither lane. Exactly. Well explained. Thank you. I hope it made sense. If you have any questions, let me know. So the last couple of concepts we went over kind of the heart of data science, all the steps that one will take to analyze data, to take a huge chunk of data, or for a computer to take a huge piece of data and make it smaller and smaller and smaller until it is exactly what you need and it is in the right order to make it the ideal set of data for a computer to process. And when I say ideal set, I mean it is so optimized that a computer can process it to its maximum efficient extent. So, what we're going to do next is we're going to practice all these skills. So even though computers normally do data analysis and do all these processes, we're going to see what it's like to do them, us to do them. And the example we're going to use is we're going to analyze the impact of climate change on local farmers practicing over the last decade. And they have measured the temperatures, the rainfall, if it's a dry or wet season, and the growth of the plant. And we're going to do all the processes that we learned to make this data as efficient as possible and find our answer. And find how, and visually, remember, data visualizing, and find how weather really affected the plant growth. So are you guys, does everybody, any questions about that? And if not, we will begin this exercise. And so here is all the data. So we can see here we have all the temperatures from the different years. And as you can see, you didn't know that at first because it's not labeled, and that's also very important about data sets. So they need to be sorted by date, they need to be labeled, and the outlier needs to be found. So I'm going to give everyone a couple minutes at first to sort all these numbers by date. And that is the first, and then give it a name. So this is millimeters of rainfall, and this is temperature. Okay, yeah, I'll write it there. I'll write it there while you're working. But so the first step is to sort them all. And the hope, while you're working, I'm just going to speak a little bit. The hope with this is that I can kind of create an understanding of what computers do always. The moment you turn a computer on, this is what it does. It uses all these importances of data analysis, of this big idea of data science, where it has a bunch of data. That's all computers, that's all they do, they process data. But in order to do that, they have a big bunch of data, and they make it smaller and more and more and more better until it is this great piece of sorted, and all the outliers are cut out, and it has been wrangled, so it's exactly what you need, and it has a name, and the computer knows exactly what to do with it and can efficiently and quickly do something with it. And that's what, like, how a computer works. So a lot of you in the beginning of class said you really liked Google. I don't know if you've ever noticed, but when you make a Google search, it says at the top how many seconds it took and how many results it loaded. I'll show you in a second. And the reason that is a cool thing to look at is because the less letters you put into the search bar, the faster and the more results it can come up with. And this is the same exact concept, that the less it has to read, the less it has to go through with, the faster it can work. But if you give it sentences and sentences, if you type a whole sentence into Google, it will take a second. Not that the human can notice. Not that we as humans can notice, because we can wait a couple seconds. But in this, the speed which computers work at, it is milliseconds or more milliseconds. And it is, but that at a high level of, when a high level of computing is needed, it's those milliseconds that count. So I am going to actually show that in a moment. So let me just stop sharing. And I'm just going to make a Google search real quick and show you guys just in Google, which a lot of you said how important it is to you, how that can be proved. So if we type in the importance of data in the real world when it comes to analyzing farmland and plant growth. So that's pretty long, right? So Okay. Okay, so now I'm going to put it back onto the screen so that you can see. And the hope is to show that please just wait one moment. I'm just putting it on my screen so that you can see it. Okay, so here I've searched two things. Here I've searched two things, and they both are in Google, and they both are at the same time and on the same with the same connection, for example. Not that is the most relevant thing, because in with Google searching, it's a little, because it's humans that are waiting for it, right? But in a case where it's actually important to compute at a high speed, for example, it's like for banks to see all these patterns. So banks get millions and millions of users, and they need to go through all these patterns and in an instant be able to block a charge. And if it takes 1 instant too long, that charge will be made and the credit card theft will happen. So they need to, in an instant, be able to block that charge. And make sure it doesn't go through. So here is what I am trying to show. So here I've searched the importance of data science in the real world when it comes to analyzing, and then I typed a whole sentence, farmland and the plant growth. And as you can see here, just with Google, something that you guys so daily have said you rely on, you can see here how long it took. So while 0.62 seconds doesn't seem like much, and no, it's not much because it's just a Google search, we got 103 million responses, okay? Now, when I type something much simpler, like the definition of yellow, which again, our data set is smaller. So when our data set is smaller and it's more crunched and it's more efficient, the computer can more efficiently run through it. So as you can see, much faster, taking just 0.27 seconds, it has come up with so many more results. It has come up with 3 billion, almost 4 billion results in just 0.27 seconds. Can you imagine that? Compared to 103 million. So while they're both a lot and they've both been done really fast, when you need really, really fast speeds for things, like blocking a charge right when it's made, you see why the small data set is important. Because just by saying going from a sentence to 3 letters, we get that much faster and that many more results, and that's a Google search. Imagine the bigger picture of computing lots and lots of data in credit card charges or lots of farmland, a huge agricultural firm. Imagine that and the speed difference in that. So I hope that you guys kind of understand better with this example, with Google, which many of you in the beginning of class said was a technology that you really strongly rely on. With Google and how the different sets of data, which in this case is our searches, here it's very long and here it's very short, affect the results and the speed. And I hope that makes sense to everybody, that example with Google, how the set of data, which in this case is a search, affects how fast that data can be processed and how many results we can get. And next time you make a Google search, because you said you guys have questions every day and you Google something, I want you to look at that. And at the very top, it says how many results in how many seconds. And I want you to notice how when you type 1 word or 2 words or something like simple, like definition of yellow, you got so many things, but when you type something a little more complicated or a little longer, it will take longer. Or with ChatGPT, which lots of you said you use, when you put in something complicated, like many paragraphs, it will load. It will take a second before it finishes typing everything. But when you put in something simple, like just ask it a question, it will very quickly come up with a big response. And that is how the data set is important to quickly processing, be able to process quicker. So sorry, I actually realized I went off the screen that you guys needed. So I will go back. Okay. So yeah, it's not too hard. Obviously, it's just busy work. It's just busy work to sort, but I kind of wanted to show what a computer does. So I will move on. And I will explain the sorting of the data. So to first create our data sets, we need to put the values in order and we need to come up with the name of them. So average temperatures, we can see here. So we have named our data set and then they are in order of date. So, so this goes all the way from 2010 to 2018. And then the same thing, we have named the data set and we have put it in order. And now let's say if you wanted to analyze the weather versus how the crop grows, you would do this. You would do the above, which we did, and you would do the same thing with the data from the plants. So the same thing with seeing how much wheat grew or how much weight of wheat grew and how much corn grew. But since it's just busy work, we're not going to do it to both, but I will do it, or I have done it to show you. And then this is on the right, if this is an image everyone can see, is kind of a more real world technological example of data science. So this is using Python to do exactly what I've asked you to do, where I inputted the data, which is 2012, 24, 2010, 16. So I put in all the different, and notice how they're in different order, and then sort the list by year, sorted data equals sorted data, and then just the code. And then that will output the result, which is, notice how the year is all in order and the numbers have stayed with the year. So this is a real world computing what data science is. It is the use of coding languages, which coding we will kind of get into more in future weeks, like Python, to do things like put the right data, make a data set, make it efficient, put it in order, and make it easy for a computer to look at. And that is obviously the first step. So what is our next step? Would someone like to share out what the next step is? So now we've kind of crunched and sorted wrangled, whatever, sorted the data. So we have nice data sets which have exactly what we want and are named and are in order. The next step, obviously, or not obviously, but is to find our outlier. So to do that, we're going to look in these measurements and we're going to see which number seems very different. Would anybody like to say in the chat or share out which number seems like it's very different? Just go ahead. Is someone in the chat or anywhere? Yes, Claire. So 24, exactly. So we have all around between 16 and 17 and 18, and everywhere it stayed between 17 and 18, 16, 17, 18. And then suddenly there's a measurement in 24 where it was very warm. So either the thermometer was broken or there was it didn't rain for a while, or or it didn't rain for a while, or something happened where that measurement was very high. Now in the second one with average rain, can anybody find the outlier? Yes, Claire has said 875 exactly. If anyone has any questions about this, by the way, feel free to stop me and just ask a question. So exactly 875, it didn't rain, that was a dry month, and therefore, or the measurement that whatever measured it had leaked it, or there was something had happened, some kind of error. So because our graphs and our averages, when we try to compare these weather measurements to plant growth, these averages will throw off a number. So we're going to do ourselves a favor and make everything easier. And we're going to cut 24 and 875. So this graph, I hope everyone can see, is another example of an outlier. So you guys can see at 24, the point goes up there. So what should have been a graph, which just stayed low because of the incorrect measurement, like what that blue line that I drew in, it's gone all the way up because of the outlier. So it is important that we find outliers for exactly reasons like this. When we try to find our average, we have an error, it pulls it up so much. And so below is the correct data where it discludes the 24 and the 875. Does that make sense, everybody? I'm going very fast, so hope it makes sense. Yes, okay, very good. Very good.
Hi, Julian. Yes, I have a question.
Yes, yes.
Okay. If we have a large data set, is there any formula we can use to find out an outlier that can make it easier to find the outlier? Is there any formula? Because looking at the data set, the large data set would be confusing to pick out the outlier. If there is no graph created, yes, with a graph, you can easily pick out the outlier. But looking at the data set that is still in its stages, is there any formula that can help pick out the outlier?
I'm sorry, I can't quite hear. Is there any way you could type your question in the chat?
Okay, just give me a few minutes.
I'll happily answer it, but I just couldn't quite hear. But once I see it in the chat, I'll stop and I'll answer it. Is that okay? Okay, so now that we have what was a bunch of data that was unlabeled and we didn't know where it came from, and we have crunched it and we've made it more and more and more efficient. It's like coming from that one big sentence to making it smaller and smaller and smaller to just be 3 letters. Now that we have done that, the final step is to visualize. And once this question comes in the chat, I'll answer it. But for now, I'll just move on to visualization of the data. So this is what the 2 graphs would look like in the end. So we would have average rainfall, and we would have average temperature. And notice how even though it looks like there's a lot of movement, it only really goes
The
between.
question in the chat has just come up.
Oh, okay. Even though I will answer in a moment, even though it looks like there's a lot of movement, it really only moves from 16 to 18. So the fact that it only moves 2 degrees is a good sign of good average. I will now answer the question in the chat, which is there a formula to pick out the outlier from a large data set? That is a great question. So obviously, if you have like a large data set, and you graph it, and then only then is it that you notice that there is an outlier. One moment, please. Only is it then that you notice that there is an outlier. It's late because you've already done all this work. You've already done all this work to crunch your data, and you have a huge data set. So to find outliers, what computers do is they look at the range, and they see, oh, for example, in the temperature, there's a range of 16 to 18, and everything is in between 16 and 18. And then suddenly there's one that's 24. So in terms of the ability for computing, it looks at this range where this average is, and then or with all my dots, with my scatter plot. Here, one moment. Here, so it looks at this range, and it says, hey, look, there's this range, which means all the answers or all the results are in between here, right? And then when the computer sees the 1 or the 2 or the exception that's not in this range, it senses an outlier and says, okay, we're going to cut this out of the data set. And this is how it does that. In terms of formula, it's a little complicated because you're always measuring something different, but with a really large data set, obviously it also takes a little longer, but the ranges can also be bigger. So outliers usually are found more in specific scenarios, because if everybody is from 165 to 185 centimeters, that's only a 20 centimeter range. So finding something that's largely out of that is not so difficult. But if you have a huge data set where you're measuring people all over the world, children, and everyone, children, adults, and everything, your range is going to be much bigger, which means the people who are tall, there'll be more of them, which means there'll be not as much seen as outliers, and the error will unfortunately mix in more. So with large data sets, it's computers more can see a range, which everything has a range, and there will always be something that's very much out of the range, but computers just look at how badly a certain set of data fits into a range, and if in that case it should be cut. I'm seeing another question, which is, please, in a case where up to like 3 or 4 outliers, what should we do? That is also a good question. Where we have, yeah, I understand. So what makes an outlier is that there's a few of them, right? So what if you have more of them? So obviously here we have how many measurements? We can't even count, right? There's lots and lots. But let's say we had someone else who was it all depends on the measurement, of course. With height, everything can have error, and if there's 1 or 2 and you're using the same measurement tools, the chance of error is higher. But if you're collecting data from all over, you can also have error, right? But obviously it depends what you're measuring. If it is plant growth and the farmer came every day and hosed down an area and gave it lots and lots of water, and it got lots of sun, and all the areas didn't get water and got lots of sun, right, and were dried out, that there would be many crops there that had grown a lot. So it all depends, to clearly answer your question, it really depends on what kind of data you're collecting. In the sense of height, if there were 3 measurements that said 250 and everyone was 165 to 185, it would still be an outlier. Because out of these, let's say 100 measurements where everyone is in this 20 centimeter range, if 3 are wrong, it's still an outlier. But let's say there's 20 where someone's 205, right? Or you're measuring in a different country or in a different area, where people are taller or shorter, right? Then it's where you can change and no longer think about it as an outlier. But of course it depends, and it's also a little bit of how it's thought about. And this is the issue with computers, because computers don't always think how humans think. And this is also the challenge with artificial intelligence, with ChatGPT. I don't know if you guys have noticed, but when you write something, it kind of comes across as very robotic and not very human-like, and not a lot of like personality in a sense. And this is because computers don't know how to simulate the thoughts and the feelings and the emotion of a human. And when they write, they will write without all that. And it's the same issue with this processing of data, where they don't know how tall a human should be, right? They don't see all these humans and say, hey, this is the height, this is the data we should cut out, and therefore kind of needs. That's the issue with ChatGPT. To get exactly what you want with it, to get exactly what you want with Google, to get exactly what you want with anything, you need to give it very specific steps so that it can understand you, and it doesn't do it from its own perspective, which unfortunately as a computer is incorrect. So yeah, I hope that kind of answered your question. Another question that Sean. You can take, for instance, measurements of heights in children, getting a different number for other, that is the outlier. Exactly. But in this case, we have a range. So if we kept this graph going to down here, and there were measurements here, then I would say, okay, right, we're measuring children, we're measuring like adults, we're measuring teenagers, and we're measuring really, right, whatever, and here's our outlier. But we have a very specific range of 20 centimeters, which means anything that when there's 1 or 2 or even 3 outside that, it will be seen as an outlier. Exactly, weighing babies. Other types of outliers, yeah, there are. Obviously error is a big one. Yes, data visualization is very, Angela, to more answer, because in the graph, it's like this. If you saw a bunch of numbers and you saw 100 numbers, you wouldn't, 200 and 185 wouldn't look that different to you, right? But if you see the graph that a dot is all the way here, very clearly see the outlier. Exactly. Any other questions? Types of outliers? Yeah, there's all different kind of types. There's types that, you know, come from error. They can come from error. They can come from just being a different set. So if you're measuring, let's say, babies, and then one's a little older and one's a little younger, right? So it's different sets, and it's different. There's many different scenarios where something is seen as an outlier. Sorry. Oh, there's no more questions. I will keep going, and I will open it up completely for questions at the end, which is coming soon. So we've gone through all this. Okay, so now we're going to look at our corn and wheat growth, and where we didn't remove the outsider because we didn't do the exercise. So this is what the data analysis or visualization looks like without the important step of finding the outlier. As you can see, there was a nice average, and then we have a nice average, but it is where the line should kind of go like this and kind of keep up with this average. It plummets down because of an outsider, which is at 550. So as we can see here, we have all numbers between 800 and 700, whatever, in the 7 and 800s, and then suddenly we have a 550. So we have an outlier. Now, where is our outlier for the corn? What is it? And or if I didn't show you this data set, how would you find it on the graph? You would look where there was a big difference. So here, it's kind of on this level where it has this range, as I discussed in the graph. Here is the range, right? It's a range between 1,000 and 900. And suddenly it changes so drastically that we can very clearly see our outlier. And I'm seeing in the chat, people are saying 600. Very good. So without even looking at all the data, because the numbers are very hard to look at, we can quickly see we have a nice average and then an outlier. And that's the same thing for the people who had questions that, what if we have two outliers, right? Here's what it would look like. We would have our graph, and then we would have in two places where it goes down a lot, or maybe here even it'll go up a lot, right? And that's what three outliers look like. They look like we have a nice average, and then suddenly in three places we go out from it. So we have this range, we still have this range, and in three places the range it leaves the range. So these three are our outliers. Okay, 600, very good. Now we'll move on to the next slide where I have removed the outliers. So I have removed both 550 and 600s. So this is a new set. On the bottom left, we can see a new set, and we can see our new data. So as we can see, even though it goes up and down a little bit, it's the range, the scale is much bigger because the range is smaller. So we still are in this tight range without any outliers, which is between like 990 and 920. Now, being in such a small, especially with kilos and crops, being in such a small range simply shows that it's a very like static and kind of very correct and accurate representation of the data. One last thing to think about with data, it's important to think about static versus dynamic data. So dynamic data is always changing. So for example, let's say you are doing something with data from stocks, the price of stocks, or the price of groceries even, anything online where the price can change. The data that this computer is using is obviously more data, but it is always changing. And the data of the footage of the camera will always be the same because it will take that footage, and that footage isn't going to change. It's going to be stored and it's going to stay like that. Obviously, more data will be added, but the previous data will stay the same. However, in dynamic data, I'll write this down, but in dynamic data, it's the way that you can think about it is all the things that you're recording, everything in your data set isn't always the same. So let's say you weigh your wheat before it's finished growing, and then it can keep growing. So this data, which you have already recorded, can grow. And that's also a part of data analysis, that your data will not always be the same. There will be many scenarios where this data can be ever changing. And yeah, I know it's complicated, but that's how it works. That's what we as people rely on every day. So that is then it we have today for our lesson on data and data science and data analysis, which was requested by some of you guys. And I hope that this I kind of taught about the important steps of analyzing data, which computers do so often. Every time you make a Google search, they do all these steps. Can you believe it? What just took us an hour? They do all the time. And yeah, so I hope that kind of the importance of data and the analyzation of it was you understand it all. If you have any questions, feel free to ask. And yeah, that's all I have. And if there's any other interest you have in technology that you would like to learn about, just like someone requested to learn about data science, you feel free to email me or ask in the chat now or say it out loud. But yeah, I will hang around for a little bit and answer questions. But that is all I have for content for today. So thank you very, very much, everyone.
Thank you very much, Julian.
What's the best software for data analysis? So it obviously depends what kind of data you're trying to analyze. So Adrian, let's say you're trying to analyze your growth, right? Since you were very, very young, since you were, a baby, or your weight. Doing that in a spreadsheet where every time you put the year and you put your weight, and then you can select those two columns in a spreadsheet and simply make a graph. And then in that graph, you can see if there's a big outlier, then you see you have an issue, or maybe you made a mistake that year. Yeah, but there's so many different kinds of data. Data is everything that a computer does. Almost everything you can think about when it comes to using a computer is data. So obviously the software when it comes to analyzing data is also ever changing, and there's many out there. All right. Dorothy is asking about, so I spoke about Python today, and it's a coding language, and I hope to get a little bit more into the coding languages, and if there's a more specific interest in Python, more specifically that. But yeah, I need you guys to let me know if there's anything you have interest in, so that I can teach you guys more about it and kind of explore that topic and show some real world applications. So yeah, Python is along with coding language is something, I'll write that down, and it's something that I hope to, in the future, we will delve deeper into. If that's it, thank you, everybody. I hope you enjoyed this lesson. If you missed anything or didn't understand anything, or if you have any friends or family that's interested in this course, there will be a recording of it on Tech Dreamers at Tech Dreamers 404 on YouTube. You just have to type into the search bar Tech Dreamers 404 and you'll find me. A recording of both this and the last meeting will be there. So if anybody has any questions or missed the first lesson on binaries, it was very interesting and very important and quite complicated. So yeah, I think that if you missed that or have any questions about that, it'd be great to go back and watch it. It's also on the YouTube channel already. And yeah, I hope you enjoyed this class. And if you have any questions at all, or any requests, or would like to learn anything, feel free to email me at julian@techdreamers.net. My email's at the bottom. And but right now, all I've written down is to talk about coding in Python. But if that's it, thank you very much, and I hope you have a great rest of your night, everybody.
Thank you, Julian. Thank you so much. Thank you.
Thank you,
Thank
Julian.
you so much. Thank you very much.
Thank you so much.
Thank you, Julian.
Thank you, Julia.
Thank you so much, Julian.
Julian, thank you. You're so good.
Thank you. Thank you, everybody. Thank you. I hope you have a good night, and I hope to see you all back next week. I'll send you a link.
Thank you. I just subscribed now.
Oh,